energy, designing the optimal rooftop solar energy generation plant, precaution and safety measures to be aware of when working with solar system product available in market. I understand people may have joined from different part of world. So good morning to them. Good evening to the people who are in Kuwait and other part of the world. I welcome you again. And today the presenter is Mr. Anil R. Lobo. So let us start with the safety moment.
Let's start safety moment.
We all are on Zoom platform, so there is a possibility.
What are the environmental benefits of solar energy? Solar isn't just great for your wallet, it's also an environmentally friendly energy choice. Here are some of the many environmental benefits you'll enjoy if you switch to solar energy. To start, solar is a renewable resource, which means it is abundant and replenishes quickly. Compare this to fossil fuels, which exist in a limited supply and replenish very slowly. Here's a fun fact. Enough solar energy hits the Earth each hour to power the entire world for an entire year. Additionally, harnessing solar energy is a low-impact process compared to harvesting fossil fuels. Drilling for oil involves digging deep into the Earth and interfering with our natural environment. On the other hand, setting up a new solar panel installation has a much lower environmental impact. This is because, unlike traditional power plants, solar is commonly installed on existing structures or otherwise unusable plots of land, such as rooftops, over parking lots, or on landfills. Solar energy is also an emission-free, clean source of power. Generating energy with fossil fuels increases carbon dioxide emissions in the atmosphere, which contributes to global climate change. Using fossil fuels also releases additional pollutants and toxins into the atmosphere and water supply. After you install solar panels, you'll use less electricity generated from coal, oil, and gas. This lowers your carbon footprint and helps protect the environment. When you compare options for solar on the Energy Sage marketplace, your quotes will show you how much pollution you'll personally offset by making the switch to solar power. Energy Sage. Smarter energy decisions.
Thank you, Ramana. So this was some of the benefit if we are moving towards renewable energy sources. So this was a detailed agenda like HSC moment we already shared with you. Welcome address done by me. And then there will be presidential address, then followed by speaker introduction, then presentation, online quiz, valid citation of a speaker, and then online certificate distribution of quiz winner and vote of thanks. Now I will invite our president, Mr. Jahid Thakur, for his address to the audience today for this webinar. Mr. Jahid Thakur.
Thank you, Sabdar. Thank you very much. Assalamu alaikum. Good evening to all. On behalf of ASSP Kuwait Chapter, I would like to welcome all for this tenure's 9th webinar on solar renewable energy. As you all are knowing that our today's speaker, Mr. Anil Lobo, who is having more than 14 years of experience in the field of safety and security, and he will brief us about what is the solar renewable energy, what is the benefit of solar renewable energy, and how to design the solar rooftop generating plant, and many more about solar renewable energy. Before going to start, let me throw some lights on upcoming event of our ASSP Kuwait chapter. We are planning our process safety management technical meet on next Wednesday, which is fall on 17th of this month, 17th November, the same time, 7 to 8:30. I would like to request all the members to participate in PSM technical meet webinar. Then one more training event we had planned on 25th and 26th and 27th of this month, which is on the topic of loss prevention at construction and general industries. I would like to request all the members to take benefit of it and participate in training program and technical meet. Thank you very much, Sabdar. Over to you.
Thank you, President Jahid Thakur. And those who had joined SSP webinar first time, in a month, we are having 3-4 activity as usual. And as mentioned by President Jahid Thakur, that there is a program scheduled on 17 and 25th, 26th and 27th. So please stay tuned for our notification. And these are some recent event we have done it, which will be highlighting our chapter activity. Like this was some of these professional development program before this Kuwait conference 2021 was on lifting plan for critical lift on 4th of October by Lieutenant Colonel Frank Tan, where 110 participants had attended this. There was another program in this one, professional development program and technical meet done by 14th October by Speaker Abdul Rahman, Abdul Latif, and Dr. Ahmad Al Yami, where 122 people attended on this Zoom meeting. And this was another program every third of Wednesday, we are meeting for process safety management. It was done on 20 of October, where Speaker Mr. Siva Ramakishore and Rahul Pateri has presented, and 84 participants has benefited by attending this. So these are some of the platform, and now this was another one-day full program on 21st of October. It was say full day program from 10 till 5 a.m., 5 p.m., where 6 speaker and 10 panelists were there, and we were having various topic of interest, and 112 people has participated and get benefit from this. This was the first physical event after COVID-19 relaxation, where people used to sit in a group, which was a wise activity. On 24th of October, where Speaker Dr. Intisar Sabra Al-Handil has given a presentation on breast cancer awareness, where 23 participants had attended that. As you are aware that 1st and 3rd of Saturday, we have our Toastmaster meeting. It is a part of leadership development. Those who wish to develop their leadership skill can attend this any of meeting as a guest, and then they can schedule themselves. We are meeting from 6:30 till 8:30, and last of the glimpses of this meeting of 30th of October and 6th of November. As mentioned previously, we are having this event, so mark your calendar, like process safety meeting on 17th of November, loss prevention and at construction and general industry certificate training session, which will be starting from 25th, 26th and 27th, and technical meet 2, it is under planning in the 4th week of November. And there is another program scheduled for DOHS, occupational health training W502, which is thermal environment. This is 1 week program. So based on your interest, you can participate, mark your calendar. Now, it is my privilege and honor to introduce Mr. Anil R. Lobo, who is also Narendra Patel is there, then it's good. Narendra, you are there? Hello?
Yes, he is there.
Yes, I am there.
Okay, so take the honor to introduce the speaker. I welcome Mr. Narendra Patel, Head of HSE Event Committee, to introduce our dynamic presenter, DTM Anil R. Lobo, Distinguished Toastmaster.
Thank you, Sabdar Bhai, and good evening, everybody. Now, it's a privilege to see DTM Anil Lobo at this platform. Let me have this opportunity to introduce him this evening. He's a leading personality in Toastmasters Kuwait fraternity. He has been a leading member in Toastmasters Kuwait since 1998. He has achieved ultimate post of DTM Reis. He had been an area director for several clubs in past years. He has been instrumental in developing ASSP Kuwait Toastmasters Club from the beginning. He has been mentoring the club for a long time. He's a wonderful speaker and we love hearing him. And certainly all of you will be enjoying his speech tonight. He has been a leading member and a mentor for Gavel clubs for children also. Anil Lobo has earned his bachelor's degree in chemical engineering from the University of Maine, USA, and his master's in HSC engineering from UPES, Dehradun, India. He is working as a head of safety and security for a regional bank since 14 years. Prior to that, he worked as a project engineer and then subsequently project manager in several leading engineering companies in Kuwait, such as Bader Al Mulla, Nafisi Engineering, Bader Al Mailem. He passionately believes in renewable energy and has ventured out into designing and installing renewable energy power plants such as solar power generation units and wind turbines, which is really a present day's demand, a green energy requirement. So let's not wait and invite DTM Anil Lobo to the platform to deliver his speech and share his knowledge and experience with us. DTM Anil Lobo.
Thank you very much for the beautiful introduction. It's a pleasure for me to give this little presentation today because as was rightly introduced, I'm very passionate about renewable energy. We live in one planet and this planet is dying if we don't do something to arrest and stop what's happening. Now, we have been dealing with non-renewable energy, which is petrol, diesel, kerosene, and so forth, including firewood in the past. And we were a smaller population, so things were working fine. Now, as the population has crossed several billion, in fact, it's, I think, over 7 billion, we need to start looking into having renewable energy. My presentation here today is about one type of renewable energy, and that is solar energy. Now, there are various types of renewable energies. We have wind energy, we have got waves, we have got even thermal energy from the soil, from the ground. Solar energy is one of the form of energy that is easily harnessed and the most widely harnessed. I'm going to be sharing my screen, and please feel free to ask questions as and when you need to, so that I can, we pause and answer some of your queries. So with this said and done, let's first start off with what is solar energy. Today, I will be talking about the components of solar system, how to design a domestic rooftop solar system, where we're going to get these solar components, and finally, some safety, environmental, and design issues that are related to the solar industry. Okay, now let's start with why we want to install a solar system. Now, these are the top 5 or 6 reasons that I have put down. The most important reason I feel is to lower our electricity bill. Most of us don't think about saving the environment. We look at how I can save my bills, my wallet. So that's the reason I put that in the number 1. The second reason is for those parts of the world where power supply, electricity is not guaranteed and assured, we need to have an uninterrupted power supply. And this is exactly, I hope you can see my screen. Can someone confirm that the screen is visible?
Yes, yes,
Yeah,
sir.
okay. Uninterrupted power supply is a challenge in the third world, in the developing world. Europe, North America, and certain parts of the world, we have uninterrupted power. But in the rest of the world, not only it's uninterrupted, there is power spikes and there are brownouts. And that causes us to put in expensive voltage stabilizers and other equipment such as UPS, either online, offline. Sometimes people even use diesel generators and petrol generators, which can cause environmental issues. So we have to look into how we can reduce our global footprint by eliminating such expensive voltage stabilizers, as well as the diesel and the fumes that come out of the cities. And finally, we need to look into renewable energy sources. There are various renewable energy sources, and one of the renewable energy sources that I'll be talking about is the solar system. Now, the best thing about solar system is you don't have to put it on prime land and agricultural land. It can be put on your rooftop, and very importantly, it can be put on barren land, hills, slopes, rocky surfaces. Any underutilized land can become your solar power plant. So now that we know why we need solar energy, we get to the next important thing. What are the components of solar system? I have listed 7 primary components. There are other smaller components which let's not talk about it because these are understood. The most important is the solar panel. Now, without a solar panel, we cannot generate energy. The solar energy, I will not go through the technical part of it, but solar energy is basically sunlight which hits the solar panel and gets converted into photovoltaic energy. And this photovoltaic cells basically are direct current DC that come out either from 12 volt all the way up to 40 volts. We cannot use this direct current straight into our house, so we need solar inverters. Solar inverters basically convert direct current to alternating current, and that can feed our electrical grid, and we can power our air conditioners and all other equipment. But there are some instances where we don't only want to have solar energy powering the grid, we also want to back it up. And that's why we have something called the power conditioning units. A power conditioning unit is a combination of solar inverter and a charge controller put together. And what is a charge controller? Charge controller is something that can charge your batteries and any other devices that can store energy. Now, this is very important to have a charge controller, especially for off-grid systems. And let me explain to you a little bit more about on-grid, off-grid, and hybrid systems as we progress. And finally, we have the battery bank and a battery management system. There are cables, isolators, and some disconnect switches. Now, let's go through each component individually. Now, the first and most important component is the solar panel. There are various types of solar panels. Each manufacturer and R&D is working on them to come up with different types of solar panels. We have got monocrystalline, polycrystalline, thin film, and right now we are working on different types of solar systems, solar panels. I'm going to spend time only on these 3 because between these 3, the monocrystalline and polycrystalline panels account for almost 90% of the solar panels. Monocrystalline is highly efficient. We are talking about efficiency rate of about 20%. In other words, 20% of the sunlight gets converted into electrical energy. The polycrystalline are less efficient. They can be anywhere from the range of 13 to 17%. But the advantage of polycrystalline panels is they are much cheaper than monocrystalline. Now, where will you use a monocrystalline? Where will you use a polycrystalline? Monocrystalline will be used in places where you have ample amount of roof surfaces. In other words, if you have a roof, like say a warehouse, and you have a small system that you need to install, which is basically to power up your, maybe a server, a few lights, few elevators, you might go with a monocrystalline panel because the rooftop is large enough. Let's go for something inexpensive. But let's talk about a small house and you have a limited roof space because you're sharing it with, it might be a row house or you might be sharing some other services on the roof, such as water tanks and maybe your elevator shaft that's on top. Here you might go for polycrystalline. Sorry, here you'll go with a monocrystalline. I just reversed it. Polycrystalline is for large surfaces. Monocrystalline is for smaller surfaces. Here you want to pack as much as you can in the limited amount of space. Now, monocrystalline panels have a higher wattage rating. The typical monocrystalline panels start at 300 watts and go all the way up to 550 and even 600 watts. Polycrystalline, on the other hand, are 300 watts and less. It can be as low as 100 and as high as 300, 350 and even up to 400. Now, if you want to look at something inexpensive, go with polycrystalline. If you want something long-lasting, limited space, go with monocrystalline. Now the next component of this is the solar inverter, or sometimes the charge control. Now, a solar inverter is the most important component because you might have a beautiful solar system, but if you cannot convert that direct current into alternating current, you basically have electricity sitting on your roof which cannot be used into your house. So, as we all know, inverters are used in a lot of households where you have small little batteries. Power fails, you run from the battery. Your car is a typical example of a battery. That's when you crank the engine, you convert the electrical current from the battery and you run it into the rest of the system. But it's only AC, so it's only DC, so it's really not a DC to AC. Now, the next component is, the next thing about a charge controller is to charge batteries. Now, your battery has to be charged if you're going for an off-grid system. Charging a battery is very important because if you overcharge the battery, you can damage it. In fact, you can even burst the battery. If you don't charge it sufficiently and properly, your battery life is reduced. So you see, the charge control is very useful in charging your battery optimally. Now, if you're having a lead acid battery, charging is not that challenging because the lead acid battery, you just need to charge it for a long period of time at a fixed voltage, typically 13 volts, 13.5 volts, 13.6 volts, and you'll charge your 12-volt battery. But when you talk about other batteries, such as lithium batteries, you have to be extremely careful because lithium batteries are very delicate and dangerous. If you overcharge them, if the temperature goes too high, they can catch fire and explode. We have had aircrafts that have fallen out from the sky because of lithium batteries catching fire. We have had planes that have to be forced to land because of that. And Samsung had phones that were pretty much exploding in people's pockets because of the battery either getting overcharged or getting overheated. So it's very important that the battery is optimally charged. Now, when you come to lead acid batteries, there are two standard types of batteries. One is what we call the standard battery, which is what we use in the car, a 12-volt battery, sealed batteries, and then you have the deep cycle batteries. The deep cycle batteries are batteries which, when you charge them, they hold a large amount of charge, which is discharged slowly over several hours, and you can even quickly discharge it, especially when you need it for like heavy equipment such as air conditioners. You can also use it for compressors, for fridges, and so forth. If you use a standard battery, the one that is used in most inverters, especially for houses, and you run your refrigerator or air conditioning, you're most probably going to blow up your battery. Your battery cannot discharge properly because it is not designed for that. And that brings us to the next topic. What type of battery you're going to use is also based on the depth of discharge. Lead acid batteries typically can discharge up to 50% of its capacity. So if you have a 100 amp hour battery and you have a depth of discharge or a DOD of 50%, your 100 amp hour battery is actually worth only 50 amp hours. So if you make your design calculation, it should be designed as 50 amp hour battery, not a 100 amp hour battery. Whereas lithium batteries can be discharged almost up to 99.5%. I mean, theoretically, you can discharge 100%. Lead acid batteries have a memory, so they remember how frequently you have charged and discharged, and it calculates what is the optimum levels. And over a period of time, these batteries got sulfur built up basically, and they die. Whereas your lithium batteries, you can discharge it and it loses its memory. The next time you charge, you can charge up to 100%. So these don't have memories. Now your charge controller has to be a proper charge controller, and that is why some companies, especially some solar integrators, use battery management system. Because in a battery management system, your charge controller will start by charging the battery really fast till it reaches about 80-85% capacity. Then it goes to a slow charge. A slow charge battery will charge at a much slower rate, a little longer period of time. And then when it reaches 99% or 98%, it will give a trickle charge. That is, it will maintain that at 100%. So it's very important choosing the right solar inverter or the charge controller, or sometimes a combination of both into a power conditioning unit, or a PCU as it's called. So these are the two types of batteries. The most common battery that we used in the solar system is the lead acid battery. The lead acid battery comes in different ratings. We have the C20, the C10, the C5 ratings. Choose a right battery. Sit with your system integrator and see what battery you need based on your application. If you're going to have lights and fans and television and you're going to have a very nominal load, you might need a smaller battery, and it might be a C lead acid battery or even one of the float batteries, the liquid batteries. Whereas if you're running your air conditioners, if you're running heavy equipment such as geysers, water heaters, pumps, and so forth, you need to have a deep cycle lead acid battery. Batteries that can have quick charge, quick discharge, a good battery management system. If you're going for something which will last longer, because remember, lead acid batteries have a very limited shelf life. They last typically from 1 to 3 years, and if properly designed, there are some batteries today that can last up to 5 years. So if you're going for a lead acid battery that will last for 5 years, make sure that you have a good battery management system so that you can charge and discharge it at an optimum level. Lithium batteries require a very sophisticated cooling system. So you cannot just put a couple of lithium batteries together and say, voila, I have a lithium battery bank. Lithium batteries need to be cooled, and there are various methods. The most efficient cooling system is using liquid cooling system, where the liquid is circulated and you have some sort of a way of venting out the heat through some louvers or fans. So when you choose the type of batteries, choose whether it's lead acid, lithium, nickel cadmium, or so forth. Choosing a battery is as important as choosing the panel, a charge controller, as well as an inverter. Now the other components are minor, but they play a very critical role also. Choosing the right AC cables is not that critical, but choose an AC cable that will live as long as your system. Now remember, your panels are going to stay on your roof for 25 years. But imagine if you have to change your cables every couple of years. The client is going to be unhappy. You as an end user are going to be unhappy because you're going to have technicians coming through your house periodically, frequently. And that's not really nice. But very important are the DC cables. If you do not choose the right DC cables, your system will overheat. And we know that DC current, there's a higher resistance, so they tend to overheat. You have to not only choose good quality DC cables, preferably copper cables, but you also have to choose the right size. Don't go with a cheap 2.5 milli cable when a 4 milli cable is suitable. Don't stay with the 4 milli cable when you need to go for a higher, like a 6 milli or even up to a 10 milli. It is better to design on a higher DC cable rather than lower. Most AC cables, especially in the domestic circuit, will be no more than 4 milli. 2.5 typically, and you can go as low as 1.5 without affecting the integrity of your system. But if you go wrong with your DC cable, not only they'll overheat, there is a safety aspect of catching fire. The next thing which is often ignored are the MC4 connectors. These are the connectors that connect the solar system to your inverters. Now if you see on the right, on the top right corner, is a MC4 connector. There's a male and there's a female part. If you go cheap on the MC4 connector, instead of spending $2 on a good quality connector, you spend $1. You might have saved a whole dollar, but you have let yourself down because a 1% or a 2% drop in your voltage, in your current, over a period of 365 days and the next 25 years means you have lost more than $1. You have lost probably a $100. So it is cheaper for you to go with a $1 system in the short term, but you have lost a lot more. And if you put a $2 or a $3 MC4 connector from a reputable brand, you have saved yourself a lot of money. Isolator switches are very important. People are very comfortable having AC isolator switches. You have circuit breakers and so forth. But very important is having a DC isolator switch. Now, why is that important? Now, imagine your solar system is generating electricity in the daytime and you want to do some sort of a service or some maintenance. You do not have an isolator switch. So what do? You take your screwdriver, you loosen the cable and you try to pull it out as quick as possible. There is a risk of arcing. And if the voltage is high, 400 volts DC, there is a risk that you will damage your inverter, or you might even cause yourself some sort of a burn, or you might even cut off your hands. So make sure you put an isolator switch where you can isolate your solar while you work in the daytime. Now, you do not want technicians to work when the sun goes down, because if they have to do some service and the solar system has to be turned off and you don't have isolator switches, and them working at 10 at night means that they're working under a lot of stress and a lot of hardships. Plus, very important, remember, you can, in theory and in practice, generate solar energy with moonlight too. Yes, you can generate with moonlight. In fact, street lights can also give enough light to generate electricity. So just when you think that there is no electricity being generated at 8 or 9 in the night, you are indeed generating electricity. And in some parts of the world, especially in North America and in Northern Europe, and in the winter time in the Southern Hemisphere, we have the sun going down as late as even 9, 10 at night. In Norway, in the summertime, the sun sets only around 11 at night. So you have to look into these factors, and you have to look into having isolator switches, not only on the AC, but also on the DC side. Very important is a grid disconnect switch. This is an often forgotten switch. Now remember, if your grid has failed and your service technicians, that is the electricity grid technicians, are working on the grid and you are feeding power into the grid, you can electrocute them. They can die. So we have to have a grid disconnect switch. Most discoms, that is the electricity boards, demand that your solar inverter, if it is being connected to the grid, has to have an auto disconnect switch. And before you install it, they will come, test, verify, and certify before they can sign a power purchase agreement with you. So these components, although they might seem insignificant, they are an integral part of your solar system. If it is not designed properly and professionally, these minor things, such as your DC cables, your MC4 connectors, your isolating switches, and your grid disconnect switch, can be a spoil sport in your solar system. Now that brings us to the two types of solar systems. There's an on-grid and an off-grid system. Like the name says, an on-grid means you connect it straight to the grid. In this case, as you remember earlier, I told you about the components of the solar system. You have got the solar panel, solar inverter, the power conditioning unit, the charge controller, and the battery bank. The first four components are the ones that we're going to be talking about when we talk about on-grid and off-grid system. Irrespective of what solar system you have, you're going to have your cables, you're going to have your MC4 connectors, your grid disconnect switch, and your isolator switches. So now let's look into the on-grid system. The on-grid system has to have a solar panel and you have to have an inverter. And this is very important. You will have a grid tie inverter. The key word is the grid tie inverter, not any inverter. Now, why is it a grid tie inverter? Because a grid tie inverter has a built-in disconnect switch when the grid fails. If you do not put a grid tie inverter, none of the discoms anywhere in the world will allow you to connect to the grid. So in other words, then you have to go off-grid. The grid tie inverter is an integral part of an on-grid system along with the solar panels. Now, on an on-grid system, you do not have batteries. Like it says, it's an on-grid system. You export to the grid. You can see the picture on the right. Item number 1 is your solar panels. Item 2 is the charge controller, which is right there in the middle. And then you have an inverter, which inverts your AC current to a DC current. Now, you do not have the item number 2 for an on-grid system. So you have 1 and then you have 4. So number 2 and number 3 are not there for an on-grid system. You will have number 6, which is a utility meter. Now, in an on-grid system, you will have a net meter, a bi-directional meter. That is, all the energy that is generated from the roof is converted into AC current and is fed straight into the utility grid. In the night, you will pull electricity from the utility grid and feed your systems in the house, which includes your refrigerator, your washing machine, your lights, your fans, your air conditioners. The net meter will see the amount of energy that you feed into the grid and subtract the amount of energy that you buy from the grid. And the difference is what you will be paying the electricity department at the end of the month. That is your on-grid system. Very simple, very easy. You don't need much engineering design. An off-grid system gets challenging. In an off-grid system, you have number 1, which is the solar system, the solar panel, sorry. Here you have item number 2, which is the charge controller, and item 3, which is the battery bank. Item 2 and 3 are the extra feature which was not found in the on-grid system. Now, in an off-grid system, you will combine the charge controller and the inverter into one unit, and you will call it the power conditioning unit. Most modern system integrators will provide you this as an integrated system. The power conditioning unit has got a lot of high-tech features also. You can have software which you can get on your cell phone to see how much electricity is being generated. You can also have it programmed in such a way that you can see how much of the battery you want charged, how much battery you want to use in the daytime, and if surplus power can be stored or it can be exported to the grid also. And finally, you have the hybrid system. The hybrid system is a combination of the on-grid and the off-grid system. A hybrid system uses a battery bank, a charge controller, and an inverter. An off-grid system, by the way, does not have the utility grid. You do not have anything connected to the grid. Now, where will you install an off-grid system? Imagine a chalet in Wafra, or a house, a nice little beach house in the middle of nowhere, a chalet on the mountaintop, and you do not have connection to the electricity grid. Then you'll go off-grid. You will store your energy in a battery bank. You will have your solar panels on the roof, a power conditioning unit, a PCU, which combines a charge controller and an inverter. And you do not have a net meter, you do not have a utility meter. Energy that you generate is used in the house. Here, designing is very important, because imagine if you design a system to generate 3 kilowatts of energy, but you need 5 kilowatts. The system will trip because you're pulling in more than you're generating. Similarly, if you install a 10 kilowatt system and you need only 2 kilowatts, you're generating surplus power, you're overcharging your battery, and you're wasting money and wasting resources. So hybrid system solves the problems of the on-grid system and the problems of the off-grid system. The problem of the on-grid system is if the grid fails. In other words, a tree falls down and cuts your power, like what happened in Texas when they had a storm. I think it was the winter of this year. There was a big storm. A lot of houses had solar systems installed, but they were all on-grid. When the storm hit, people were without power for several days. It happened even in India. There was a cyclone in the west coast of India, on coastal Maharashtra, Kerala, and Goa. And there was no electricity for several days. People who had on-grid systems were in the dark, although they had solar system on top. If you're off-grid, you're spending a lot of money on batteries. So when you go hybrid, you say that you have optimum amount of batteries, but not a very large amount, because you prefer to go on grid in the nights, and in the daytime you use the solar from the sky, from the sun. And on those cloudy days and those rainy days, you have a battery bank that gives you power in the daytime. So these are the 3 primary types of solar systems: on-grid, off-grid, and hybrid. Now let's understand the advantages and disadvantages of each system. The on-grid system is very cost effective since there are no batteries. Now batteries are the most expensive part. One battery, a simple 200 amp hour battery will set you back almost around maybe in equivalent in Indian rupees will be 20,000 Indian rupees. In dinars, it comes to approximately around 100 dinars. That's a lot of money. So imagine you have 20 batteries, 100 dinars times 20, that's 2,000 Kuwaiti dinars. Now, if I'm going to invest that much money into batteries, let me think about it. Do I want to go on grid or do I want to go hybrid? Second thing, it's easy to install. What do you need to do? Anyone can install solar panel on the roof. An electrician can bring the wire to your. Somebody is speaking. Can you mute them, please? So you bring a cable from the solar panel. We call it a string. You bring the string down to the solar inverter. Terminate the strings in the solar inverter. Turn the solar inverter on, and voila, you have converted your DC current into AC current. Easy to install, no programming. You don't need to have a rocket scientist to do this. The best thing is you get money. You sell the electricity to the grid using a power purchasing agreement, PPA, and you buy it in the night based on the amount of electricity you generate in the daytime and how much you use in the daytime minus the amount of energy you use in the night. That's how much you're going to earn revenue. Putting a solar system on the roof, you're generating electricity for the rest of your lifespan of the solar system. Your solar panels typically are warranted, a performance warranty of 25 years. It doesn't mean that on the 26th year they stop working. It just means that they will perform with only about 5% loss of efficiency for the first 25 years. They will continue working up to 40 years, even 50 years. But the performance is not dropped to only 5%, it might drop down to as much as 20%, but you will still be generating electricity. The thing you might have to change after 25 years is the cabling and maybe your inverter. And that's the reason the maintenance costs are very low. You don't need any technicians, you don't need to have put a contract, an agreement or some sort of a maintenance contract with anyone. You can do it yourself. You can check the systems yourself. The biggest drawback, unfortunately, is when there is no electricity from the grid, you have no electricity in your house too. So in other words, if there's a storm or if the grid fails or there's a maintenance on the grid, you do not get electricity. And this happens to be a big drawback, especially if you live in places like India, in Africa, and in some parts of the world where you have an issue with grid failure. The second drawback with such a system is if you live in an area where the grid has got a lot of disturbances, in other words, there are harmonic disturbances due to a factory or a refinery close by, that disturbance will come into your house and can mess up your electronics in the house. Because remember, the electricity you generate, you're not using. You're giving it to the grid. I'll give an example. This is like you're a tomato farmer. You grow 100 kilos of tomatoes. And what do? You keep the tomatoes in front of your gate and you tell the electricity department, please collect my 100 kilos of tomatoes. If the electricity grid fails, the tomatoes rot in front. You've generated the electricity, but nobody is using it. So at the same time, you want to buy electricity or you have to buy tomatoes, you have to go to the market and buy at the commercial rates. If electricity is not available, you don't get tomatoes. You understand what I'm saying? When you need the tomatoes and if the tomatoes are not available, you cannot have tomatoes to eat. And the same thing applies with on-grid system. When you want electricity and the grid has failed, you cannot get electricity even from the system that you have on the roof. There are ways to work around it, and that is by having a hybrid system. Now, an off-grid system has overcome the drawbacks of a on-grid system. In other words, it is independent. The grid is working or the grid is not working. You are generating the electricity from your roof and you're using it for your house appliances. Any surplus power you have, you put it into your battery. Now, off-grid systems are becoming very popular in third world countries where electricity rates are quite high, where electricity is unstable, either because of voltage fluctuation or because of a lot of harmonic noises in the system. And there's a third reason. people are now migrating towards electric vehicles. So if you have an electric vehicle, especially an electric scooter or an electric car, you can use your surplus electricity to charge your electric car free of cost. In other words, when you drive your car, it's like somebody putting free petrol into your car. So off-grid systems are becoming very popular to charge your vehicles, and they're becoming very popular all over the world too now. Another advantage of off-grid system for places where you don't have a grid line, remote hill stations, places where the trees can fall and cut you off, beach resorts, islands, even mobile vehicles such as mobile campers, boats, ships. I've seen in Kerala the backwaters, some of the boats on the backwaters, they're using off-grid solar systems to provide electricity and energy for the boats. So these are the advantages of an off-grid system. The only drawback of an off-grid system is it's expensive because of the battery. The battery has to be changed every 3 to 5 years. And the second thing is they are expensive not only to design and install but also to maintain. You have to have a proper designer. If it's not designed properly, you will have a problem. If it's over designed, that's fine, but you have spent a lot of money. If you have not designed it efficiently, you will have blackouts when you turn the pump on or you turn the air conditioning on. Now, the drawbacks of an on-grid system and an off-grid system have been taken over by the hybrid system. What the hybrid system says is, when the grid fails or if there are cloudy days, you run on the battery. If the battery is not strong enough or is not large enough to run the load, it draws from the electricity grid. You can even charge the batteries from the electricity grid. In a hybrid system, you can also add, if you want, an external power source such as a mobile battery bank or a diesel generator or a petrol generator. Failure of a grid will not affect the system. So a hybrid system is a perfect system for people who want to install a solar system, are not interested in having a system which can fail if the grid fails because they have some elderly people in the house or they have systems that are very sensitive and delicate, such as computer equipment and other related equipment. This is very important for factories and workshops. Companies, offices that have servers need to go for hybrid system. Houses where you have children who are studying for examination and they're doing online, where people have elderly parents who will require 24/7 electricity, will go for a hybrid system. Now that we understood the different components of solar system, we have understood the 3 different types of solar systems, the on-grid, the hybrid, and the off-grid system. Let us see how we can design a solar system. At this stage, I'm going to pause and ask, do we have any questions? Okay, I'm going to ask our poll master if you can launch one of the polls to see if people have been paying attention to what I've been saying. So, Ramana, do we have a poll that you would like to launch?
Yes, actually, I'm going to post a Google form at the end.
Okay. So while you're doing that, let me continue with my presentation. Okay. Now I'm going to spend the next 20 minutes explaining to you how to design a solar system. Now, as you know, the components are very simple. Number 1, you have to have solar panels on the roof. Number 2, you have to have something to convert the solar energy, the DC current, to AC current. That could either be a solar inverter or a power conversion unit. Syed Arif, can you mute yourself, please? So here we can look at how we can convert now the DC current to AC current. It could be either solar inverter or a power conditioning unit. Then the third thing we need to ask, do we need a system that's going to work in the nights using battery, or are we going to be on grid? So are we going to go with an off-grid system, an on-grid system, or a hybrid system? And finally, we're going to ask ourselves how long we want to have the system work on battery in the night. Once we understood this, Then we move to the design stage. Now, in order to design properly, we have to understand the load that is required. Now, an on-grid system is very simple. There's no designing. You look at your electricity bill and it says your sanction load is 5 kilowatts. Your DISCOM will allow you to install only 5 kilowatts of solar system. There's no engineering involved. You can install 1, 2, 3, all the way up to 5 because your sanction load is 5 kilowatts. You cannot install 5.01 because they will not allow you to connect to the grid. So your system that is installed has to be scrapped. If you have a 10 kilowatt sanction load, you can install up to 10 kilowatts. But here, if you're designing a system which is hybrid or off-grid, you need to understand your load. What is your day load? What is your night load? And what is your evening load? Now, in the daytime, there are certain devices that you'll be running which you'll not run in the night. Your washing machine you might run in the daytime. Your water pump you might run in the daytime. A lot of other gadgets.
മീറ്റിംഗിലാണ് ഞാൻ ഇവിടെ ഉണ്ട്
Can you mute yourself, please?
Done.
Yeah, thank you. So you have to ask yourself, what is your day load? And then similarly, what is your night load? Will you be running your air conditioners in the daytime or in the nighttime or both in the day and night? There are certain devices that are going to run 24/7. Your refrigerator is going to be running 24/7. There's no re-engineering about that because your food has to stay cold day and night. You might want to run your internet router all through in the daytime as well as nighttime. Your CCTV system and some of the other equipment that might be running both daytime and nighttime. So you have to ask yourself and write down what are your day loads, what are your evening loads and night loads. Your perimeter lighting, your house lighting will only run in the evening time, and when you go to bed you might turn some of them off. So you have to do that calculation. The third thing you need to look into is the quantity and the type of panels you want. Now you remember at the very beginning I talked about monocrystalline and polycrystalline. Monocrystalline is more expensive, but that's because your roof space is less. If you have a large enough roof space and you need to work on a tighter budget, you can go with a polycrystalline panel. But if your roof space is small, you want to go with a monocrystalline panel. Second thing is you might have a tighter budget. Instead of having, say, 5,000 dinars, you might have 3,000 dinars that you want to invest. So go with a smaller panel. Can we mute the people, please? And can you make sure that people cannot unmute themselves except for me?
Yes, I have done, but I don't know how they are unmuting. I'll try.
Thank you. No, that's fine. So the next you need to know to check is the number of panels that you're going to have on the roof and whether you're going to have an expansion or not. If your budget is half of what is your requirement, you can start modular. You can put a 2 kilowatt system expandable to 5 kilowatt. So your power conditioning unit will be a 5 kilowatt power conditioning unit, but you start with only 2 kilowatts of solar panels. Every time you get a surplus money, you install another 1 or 2 kilowatts until you reach your 5 kilowatt capacity. So based on your roof space, based on your budget, and based on the number of kilowatts you need, you will choose the quantity and the type of the panels. And that is why this is where you need to sit with your system integrator and explain to him what you need, how much is your budget, and what is the size of the load in your house. Now that you've got that part done, the next is the angle. Angling of the panel is critical. In fact, 90% of the failures of solar system is because of the angles. Yes, I'm saying 90%. People think that just because they have a flat roof, they can put the solar panels flat on the roof. You have to angle your panels facing south. If you put it in any other angle, you are minimizing the optimum use of sunlight. If you put your solar panels facing north, you will get no energy or limited amount of energy. The panels could be facing east and west, where you're only going to get 4 to 5 hours of energy. But if they're facing east, you can get as high as 8 to 9 hours of energy. So it's very important in which direction, and I'm talking about northern hemisphere, it depends on which direction you put your solar panels. Now also the angle of the solar panels is very important. You cannot keep it flat because the angle of incidence is not the best. So you have to tilt them at a specific angle. Based on how far you are from the equator, you have to choose the angle, and that's where your system integrator will choose the right angle. If you are in India, the typical angle is between 22 degrees up to 32 degrees or 35 degrees from the horizon. If you're in the northern hemisphere, the angles can go as high as even 45 degrees. So choose the angle of the panel and the location of the panel in coordination with your system integrator. If your system integrator is not very good, you can go on Google and check what is the optimum angles of your panel. You might have to modify the civil structure of your roof by putting some sort of a steel frame if the angle is not optimum. Example, if your roof is facing north, you might have to tilt that so that it's south facing. So aesthetically it might not look good, but you will get the optimum amount of sunlight on your solar system. The next is you're going to look into your battery calculation. You want to ask yourself, how much battery backup do I need and how big my battery load is going to be. Now let's see, if you're going to use your air conditioners only for 3 months in a year, which is in the months of April, May and June probably, do you want to design your solar system to have the air conditioner? Maybe you'll use the AC in the rest of the year for only 1 hour or 2 hours. So you want to have a smaller battery because the number of hours you're using the air conditioning is negligible, minimum. So you can run that on the grid. But yes, you're going to use your washing machine almost on a daily basis. You will have your microwave, you will have your induction cooker, you might have your water pump, you might have to have your fans, your lights, your TV, your computers and so forth running on the battery even in the night time. So that is when you look at the battery calculation. Plus, if you're going with a hybrid system, you can ensure that if the load exceeds your design capacity, you pull in power from the grid. So this way you don't have to go with a large battery backup. The battery is when the main grid fails, you know that you can use your battery in the night or in the daytime to get the power for critical equipment. Two other criteria that you have to look is the distance from the solar panel to the PCU. Now remember, the solar panel sitting on the roof is running down to your power conditioning unit is a DC cable. You want to minimize the cable run because of loss of energy. The loss of energy in DC systems is much higher than in AC systems. So you want to keep your solar inverter as close as practically possible to the solar panel. In fact, there are some solar panel manufacturers who have built-in inverters with their solar systems so that you generate DC current into AC current right at the rooftop and you're bringing down AC wires. It's not the most efficient design because it costs a lot more money too, but it is something worth looking into. If you can put your inverter on the roof rather than on the ground floor, that's even better. So the distance between the panel and the power conditioning unit is very important, or the inverter is very important. Equally important is the distance from the power conditioning unit to your electrical DB. The longer your cable runs, the more wastage of electricity there is. So you want to keep your cables run to the bare minimum. Sizing of your power cables are very important. If you use the wrong size cables, especially on the DC side, you will have some serious safety issues. And I'm going to touch upon them towards the end of my slide. Now, another very important part is the termination. You will not want to put joints, especially on the DC side. Any joint in your DC cable will cause the cable to overheat. And this overheating can have a cascading effect by lowering your energy consumption or energy available and also causing an electrical fire. So you want to avoid joints. If for some reason your cable has broken, you take the cable out and you put a new cable in. Do not have joints like how you would do with AC cables. And termination is very important. And there's a reason why I'm telling you terminations are important. In humid, corrosive environments, especially along the coastline, all the way from Gujarat down to Kerala and from Tamil Nadu all the way to West Bengal, These areas in India have very corrosive environment. If your terminations are not done properly and the joints get corroded, you will lose a lot of energy. And that is why I strongly encourage, and installations that I do soldering of the cables for the MC4 connectors. And I ensure that it is taped up to prevent any moisture ingress. So these are the factors that you have to look into while designing. You have to sit with the system integrator to ensure that your batteries, your solar panel, and your power conditioning units are sized properly. If these things are not sized properly, you're in trouble. Your angle of the panel has to be proper, and the distance of the panel to the PCU has to be as close as practically possible. You choose the right size cables and you terminate them efficiently. And that takes us to some of the safety concerns. Now that we have done a good job, we have installed a solar system, there are some concerns. And being safety professionals, let's talk about them. DC current is very dangerous. In an AC system, we have circuit breakers, and the circuit breakers can trip. There are DC circuit breakers too, and people have installed them. But remember, DC current is a straight current, so even a momentary shock can kill you. Some of the DC currents can go as high as even 400 volts. They can cause very serious burns. On your AC side, your typical voltage will not exceed 220 volt unless you're working with three-phase system where it can go to 415 volts. But your DC systems can go as high as 400 to 600 volts DC. So you have to be extremely careful with DC side of the solar system. The second thing is your AC equipment. You can use your standard AC testing tools to determine whether that it is working or not. Your AC testing equipment does not work on DC. You have to use specialized DC tools which are used by low voltage technicians. But now the low voltage technicians work on 12 volts, at the most 24 volts, and in very rare cases they work up to say 48 volts DC. But here you're going to 300 and 400 volts. So you have to be very careful what type of testing equipment you're using on the DC side. The third problem is it should not be AC, it's DC cables overheating if it's the wrong size. Now, DC cables and designing of DC cables is an engineering calculation. You have to do a proper DC voltage and current calculation. The length of the cable, the size of the cable, the load that is being used. If you don't do it properly and you just guesstimate and use the same numbers as you expect for the AC, you are in deep trouble, because the moment you fire up the system, you're going to damage first the insulation. When the insulation cracks, the cables are going to touch each other, they're going to short out. Once it shorts out, it'll overheat and can cause a catastrophic fire. If it is next to a battery, the battery itself can explode. And the battery, these are acid batteries, lead acid batteries. The lead acid batteries are corrosive, and if they are in your house, they can cause very serious flow damage, wall damage, and even sometimes the fumes can be quite toxic. They produce hydrogen gas, which is explosive. Large amounts of hydrogen gas in a confined space can cause an explosion. So we have to be very careful with the batteries too. If you overcharge the battery bubbles up, and over a period of time, the battery can start leaking. If you undersize the battery, you're not giving enough charge to the battery, the lifespan of the battery is reduced. So you might have a 3-year warranty. And what will the guy do? He will just change the battery and you'll have the same problem. So you have to re-engineer. You have to look into sizing your battery correctly. The next thing we have to look into is working at heights. Now remember, solar panels are going to be installed on the roof. When you work on the roof, you have a lot of issues of working in heights. You can slip and fall, and equally important is not only you falling from the roof, you could drop something on the people below, especially some of the tools, or maybe even the panel itself, or the supporting structure can fall on the people below. So you have to be very careful when you're working at heights. If you do not have isolators, this becomes a challenge, especially when you're servicing the equipment. Now, why is this a challenge when you're servicing the equipment? A normal technician will think that there is no sunlight, and he will start working on the DC part of the cable. And the little moonlight that is out there is generating enough electricity to give him a shock. Sometimes it could be just you're at the wrong place at the wrong time, or it could be that you have taken all the precautions, but the isolators have not kicked in at the right time. And then there's poor maintenance. The poor maintenance can be a variety of reasons. It could be that your inverter has not been serviced. The dead insects and the dust buildup has not been cleaned. You have not checked the battery terminals. Maybe the gas is leaking and venting. The battery acid levels have dropped down and it's not been topped up. Any poor maintenance can affect the system. And there is another safety concern, especially when you're installing in a corrosive environment, an environment where you can have storms such as cyclones and strong winds, the monsoons, especially in India. If you do not check the structural integrity of your metal frame, when the winds blow, the monsoons, your whole solar systems can blow away, especially if you have very strong winds and strong storms. So you have to be very careful and make sure that maintenance is done on a regular basis. These are just some of the basic safety concerns. There are a lot of other concerns, and we can think about it and work on it on a case-to-case basis. There are three major environmental concerns. One of the biggest one is disposal of lead-acid batteries. Certain parts of the world, there are legislations, like in Europe and North America, there are legislations, and even in Australia and other countries in the world, there are legislations on how to dispose of the battery. The battery has to be given back to the supplier before you can get a new set of batteries. In third world countries, the disposal of the battery is quite dismal. You can even dump it in your trash can or leave it by the side of the road. So this is an environmental issue. The other environmental issue we have is the leaking batteries. When these batteries leak, they have acid, they're very corrosive. The lead itself is very toxic. The buildup of lead in the body can lead to a lot of medical and health issues. And finally, if a panel is broken, a solar panel is broken or it's faulty, there is no way of having it repaired or rectified. It's quite expensive, and the chances of it being repaired to the same efficiency as a brand new panel is less. So how do you dispose this off? And this is becoming a big problem today in certain parts of the world that have moved very aggressively towards installing solar system. They have a lot of panels that are now faulty or obsolete, outdated. Maybe a 30 kilowatt panel, the person is upgraded to a 300 kilowatt panel, and we don't know what to do with the 30 kilowatt panel, and they end up in landfills. So we have to look into how we can dispose this off. So these are some of the environmental concerns. And finally, some of the design issues. When you're designing a solar system, you have to go to a professional so that you can think about future expansion. Now, once upon a time, the greatest thing that you could think about is having a washing machine in countries like in India. Today, every house has washing machines, and people are now moving into dishwashers. Once upon a time, people were content with having domestic help come and vacuum their houses or clean their houses and so forth. Now people are going for Roombas, which are basically little robotic vacuum cleaners that do cleaning of the house while you are at work. So these are electronic gadgets that are kicking in. People did not have internet routers and CCTV systems in the past. So when you design a solar system, look at the future expansion. What are the future things that you'll be putting into your house? Electric vehicles are one of the greatest designing challenge to a lot of the older solar systems. People installed a 5 kilowatt solar system in the past without thinking of them going for an electric vehicle. Now that they have an electric vehicle, they need another 3 kilowatts to charge their electric car. And what are they doing? They have to put a brand new system because their existing system cannot expand to charge the electric bike or the electric car. So let's look into potential future expansion as newer technology and newer equipments get put into your house. The second challenge is service technicians. You might go with a cheap solar system, something that is inexpensive. But ask yourself, if something goes wrong, how long will the technician come to fix your system? Now imagine you live in a country like India and your closest technician is about, say, 4 or 5 hours away. And he tells you, if I come, you need to arrange accommodation for me too at the nearest hotel because I'm spending 4 hours coming there, another 4 hours working in a system, I cannot go back home. So your cost has gone up. You have a cheaper system, but your service cost goes up. And that can get exacerbated if the service technicians don't keep spare parts, because they're a small operator, and for them the cost of keeping spares is quite high. So every time you need a spare part, you have to wait for a couple of weeks till it gets shipped to you, and then he will come back again and reinstall the component that's faulty. So you have to look at how you can get your system serviced. Spare parts should be available, especially for the power conditioning units as well as the panels. The third thing is you need to look into optimizing the panels as well as the power conditioning unit. It's okay to over-design, but you're wasting money. That same money could be utilized to some other resources. And the worst thing that can happen is you under-design your power conditioning unit or the panels. And here you are, always running on the grid. You've spent, say, $10,000 on a solar system, hoping to reduce your electricity bill by $1,000. And lo and behold, at the end of the year, your electricity bill has not dropped down by $1,000, but it's only dropped by $500. So you expected to recover your solar system cost in 10 years, and now it's going to take 20 years, which is not the most effective way of doing your calculations for installing a solar system. The fourth reason is your location of the roof. Please make sure that you inform the solar integrator about the challenges of putting the panels on the roof. Once you sign the contract and bring the panels to install on the roof and you tell them, oh, I don't have a proper roof surface, that is a challenge. I had this problem with one of my relatives, my cousins. They ordered a solar system to install in their building, but they live in a housing society, and the housing society refused to give them permission to install it on the roof. So he installed it in the veranda of his house. Unfortunately, the veranda was getting sunlight for only 3 to 4 hours a day, because when the sun went on the other side, he was getting shade. So he installed a very expensive solar system to give him only 4 hours of electricity, which was really a waste of money. So you have to be careful when you are installing solar system to make sure that the panels can be installed on the roof in the right way. You have to also look into the battery replacement cycle. Keep aside sufficient money to buy new batteries every 3 to 5 years. But very importantly, make sure your battery management system, that is your charge controller, is a good quality charge controller. There are some very inexpensive Chinese, Indian, as well as European manufacturers that offer you low-cost battery chargers. But what are they doing? They're damaging your equipment. It's like you're buying a very expensive iPhone or other device, and then you use an inexpensive, unbranded charger. You're damaging your cell phone the same way you're damaging your battery by putting an inexpensive or a cheap charger. And finally, you have to do periodic maintenance. You do periodic maintenance on the panels on the roof. You clean them, just regular water. Soap and water is good enough, but plain water is fine. Make sure the cleaning is done at an optimum time so that you don't accidentally damage the panels by stepping on them or so forth. And you choose a time of the day when it's bright enough, but it's not peak sunlight time. Check your system, especially before the storms. You check the structural integrity of your roof. Make sure that all the cables are properly anchored well. The frame where you're installing the panels are bolted well. There's no corrosion. There's no rodents, rats, and birds that have made the homes in your solar system, because that's giving them nice shade from the sun, right? So with these design issues, environmental issues, and safety issues, we now come to the end of my presentation. In conclusion, we understood the different components of the solar panel. And now we're going to have a few quiz questions to see whether you remember this. What are the solar components? We have the solar panel, we have the charge controller, we have the inverter, we have a battery bank. In addition to this, we have the supporting equipment, which is our cables, AC and DC cables. We have our isolators, and we have got our grid tie connectors and the MC4 connectors. So these are the components of the solar system. There are 3 types of solar systems: on-grid, off-grid, and hybrid. We learned the advantages of on-grid and the advantages of off-grid. The disadvantages of the on-grid and the off-grid are taken care of in the hybrid system. So the hybrid is the most optimum system that everyone wants to go for, whereby you get solar energy in the daytime, battery in the nighttime, And if you need extra electricity, you get it from the grid, especially in the summer months when you need to turn your air conditioning on. So we've understood the advantages. We learned how to design a solar system. We learned the components that are needed to design a solar system. We looked at some of the safety issues, the environmental concern, and the design concerns when we're working on the system. Now I ask you, do we have any questions? Let me ask if you can have the polls launched. Okay, we have our first poll launched over here. It says, which of the following is not a component of the solar system? We have the charge controller, the solar panel, the limit switch, and a grid isolator. Very good. All those who answered limit switch. Oh, great. We have people who are still answering the question. So very good. 22 out of them have answered. All we have got another 20 people who need to answer. I'm going to count down to 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So let's see the results of the poll. And the results of the poll says that it's a limit switch which is not a component of the solar system. All those who answered that, that's 28 out of 30, you're right. The charge controller is an integral part of the solar system. The charge controller is used to charge the batteries. The solar panels are what you get converted from DC to AC. And your grid isolating switch is needed if you're having a grid-tied solar system. Excellent. So now let's have the second poll, the second question. What is one advantage of the on-grid solar system? Okay, which is the one primary advantage? There are 4 potential answers, but there is one advantage of an on-grid solar system. Okay, great. We'll just count down from 5, 4, 3, 2, 1. And let's close the polls. And now we see the results. Okay, some of you said it works round the clock 24/7. Now, on-grid solar system works only when there is sunlight because it is connected to the grid. When the electricity comes, it goes straight to the grid. So sadly, it doesn't work round the clock. Round the clock works for a off-grid system which has battery backup. So those who answered that, there are 10 of you. I'm sorry to say that that's not the right answer. Let's look at the bottom one. Works during electricity grid failure. As I told you, if the grid fails, the solar system and on-grid system doesn't work. Although you're generating electricity on your roof, during a grid failure, you get zero electricity. So sadly, number 1 and number 4 are both wrong. Now let's look at number 3. Surplus power is stored in batteries. An on-grid system does not have batteries. So an off-grid system is the one that has battery and a hybrid system. So the right answer is the low maintenance cost. That is the primary reason why people go for an on-grid system. They say, let me use the little money that I have, put solar panel on the roof, and get some money from the government or from the electrical supply, the DISCOM, the grid companies, and it offsets my electricity bill. If they can save just $50 per month, that's $600 a year. Over 10 years, that's $600. And if the system costs them $2,000 to install a very simple on-grid system, they have recovered 2/3 of the value of their solar system, plus they have increased the value of their home. So that's great. So those of you who answered low maintenance cost, and there's only 24% of you, that's the right answer. Let's get to the next poll. The next poll, what is one advantage? What are the two design issues with the solar system? There are two answers over here. So you have to answer, you have two choices. You can answer either 1, 2, 1, 3, 1, 4, or 2, 3, 2, 4, or 3 and 4. I do not know whether you're allowed to have two polls or not, but at least if you can give one, that'll be great. So two design issues with solar system. I know it says single choice, but it should be two choices. Okay, we have only 7 who have answered so far. That's fine if you answer only one out of the 4, that's good enough. Oh, we have relaunched the poll. Okay. I guess here we can have 2 answers, right? Okay, we've got almost half the people have answered. We'll give them another 20 more seconds. Okay, I think it's time to close the poll. 5, 4, 3, 2, and 1. And now let's see. We have 4 answers. Which are the 2 design issues with the solar system? Leaking batteries, unfortunately, is not a design issue per se. Why? Because leaking batteries can be a variety of reasons. This is more of a maintenance issue, but this is not a design issue. Breaking of panels. Once again, breaking of panels is not a design issue. This is more of an installation issue and a maintenance issue. But periodic cleaning and poor maintenance are very important. If your system is not cleaned regularly, your solar system efficiency will drop. Let's say you have got a 5 kilowatt system installed on your roof. You have not cleaned it. There are dust, leaves falling on it. Over a period of time, there's a buildup. And what happens? From 5 kilowatt, it drops to 4.7 and 4.5. And within 6 months, the dust has built up to a point where you get less than even half the energy. So periodic cleaning is very important. And the second one is maintenance, poor maintenance. If you do not service and maintain the system properly, that answers the first issue of leaking batteries. So the leaking of the battery is not directly a design issue, it is a maintenance issue. So if maintenance is not done properly, and for this, you have to look at the supplier. Does he have a good maintenance team? Is the maintenance close by, or they have to travel large distance from your installation? So I'll give an example. If you live, like say in Salmiya, and you have an installer coming all the way from Dammam, Saudi Arabia to service your system, you're going to have a lot of maintenance issues. Similarly, if you have a contractor from Bombay who installed your system and you're living in Chennai, the very fact that he has to fly into Chennai every time to service your system is going to cause you problems. So you have to look into how maintenance is being done. And now we get to our next poll, I guess our final poll. What are the safety concerns with solar energy? Now here there's one important safety concern, or maybe more. Okay, we've got more than half. All right, so let's stop the poll in 5, 4, 3, 2, 1. Yes. All those who said battery overcharge are a safety concern. Yeah, it is a safety concern, but it's not really as much of a safety concern. This is more of a improper design. If the battery is overcharged, yes, it can cause a fire. So yes, it is a safety concern, but that's more of a design concern. Cables overheating due to wrong size is a very important safety concern because the cables can overheat for a variety of reasons. Now remember, it's DC systems. If the insulation has burnt out, that means it's a maintenance issue that can cause it to overheat. If you're drawing too much current, it can overheat. On a hot, sunny day, and if I put them in metal piping, they can overheat and it can catch fire. So fire is a very big risk in solar systems. So overheating of cables due to wrong sizing. Lack of spare parts, I'm very happy nobody said that because it's not true. And those who said all of the above, to a little extent, except for spare parts, yes, battery and cables overheating are safety concerns that we have to look into. So with this, do we have a fifth question? I guess not. Great. Yeah. So now,
Anil,
yes.
thank you for a very nice engaging presentation on this solar renewable energy. There are 4 questions posted by different individuals. If you allow me to read for you.
Please.
There was a question from Mr. Simon Joseph that his area has frequent lightning and how it affects this solar panel and the whole process.
Very good. In fact, lightning issue is a very big challenge, not only for solar installations, but in general. A lot of the households don't have lightning arresters and they don't have proper earthing. So whether you install a solar system or you don't install a solar system, it doesn't make a difference. You have to have lightning arresters in areas that are prone to lightning strikes, and you need to have proper earthing. Earthing pits have to be proper. They are preferably to have chemical earthing pits. Now when you have a solar system, the solar panels by itself can draw a little extra lightning to you because of the metal frame that is being used to mount them on the roof. So whenever you install a solar system on the roof, ensure that you have a lightning arrestor mounted adjacent to it, drawing the lightning away from the solar panel and straight down to the ground. In addition to that, you also want to have some sort of a earthing protection, especially for your power conditioning unit. That is going to be, highly regulated, so you have to look into this. So thank you for bringing this up. It's a very important criteria to look into.
Thank you, sir. There is another question. Is it mandatory to install lightning protection, especially if a house is nearby high voltage like 11 kV line?
Okay, lightning protection is one issue and earthing is a separate issue. Lightning protection is important in areas where you have lightning storms, especially in areas where you have had in the past lightning. Again, the meteorological department will advise you on areas where you need to have, which are highly prone to lightning. But in general, any structure that rises above the ground by more than 5 meters and is surrounded by no other higher trees should have lightning arresters. If you have coconut trees adjacent to you, there's a very good chance that they're going to take the lightning away from you. But if you have metal roof structure, you have to look at lightning arresters. Now, 11 kVA lines, it all depends how far they are from your home. There is, in addition to the electricity generated, you also have got some sort of electromagnetic issues that you have to look into. So unless I speak to the person and I know what exactly he's talking about, I cannot answer that question with clarity. So whoever's
That's fine. I will see that person is available to engage you in this. There is another gentleman, Mr. Imad Konsoa. His question is, why still most of the country did not start this solar energy system? This cost more than the normal energy.
Okay, very good. This is a nice question. Now, solar energy is a great renewable energy, but it's not for all parts of the world. Remember, temperature is a very key component in solar energy generation. In other words, as the temperature keeps rising, the solar efficiency keeps dropping. So let's say the optimum is at 25 degrees Celsius, which is 77 degrees Fahrenheit. So a lot of our solar panels are rated at that as being the optimum efficiency. Every 10 degrees that your solar system rises, you lose 5% efficiency. So now in Kuwait, your surface metal temperature is about 85 degrees, okay, just for math purposes. 85 minus 25, can anyone tell me how much is that? That's 40 degrees, right? 60 degrees, sorry. So that's 30% loss of energy. And that is the reason why solar systems are not the best to put in the Middle East, in places like Delhi and Rajasthan and desert areas. So although they get a lot of sunlight, they get, in fact, the most amount of sunlight, you're losing 30% efficiency in those areas. The best place to put solar system is in very cold countries where the temperatures are as close to 0 degrees Celsius. So your geographical location, the temperature plays an important factor. High elevated places are much better. Cloudy places, not as good. Places where it rains, yes, solar energy is not really rain dependent because as long as enough sunlight and enough ambient light comes on the panels, they can work. So you have to choose the location optimally and efficiently. And that is why it's not a most common in all parts of the world. Some parts of the world, yes, more than others. Now coming to the very important part, why people are not going for it. It's expensive. Although solar prices have dropped by almost 50-70%, they're still quite expensive. Your recovery cost can vary as much as 5 to 7 years on an average system, and for a larger system can be as high as even 10 years. People don't want to wait that long. They are willing to spend small amounts of money every month rather than put in a big system which costs, say, $25,000, and they are happy spending $200 every month. So that is the second reason. So to compensate this, a lot of countries are going and giving subsidies. One of the countries that is very aggressive on subsidy is India. India has got a very aggressive goal of migrating to solar energy. And the rate in which it is growing is really exponential, double digits growth, almost triple digit growth. 20 years ago, solar energy was insignificant. Today, solar energy comprises almost 10% of the total energy generated. And by 2050, almost 50% of the energy in India is probably going to be solar energy. So that tells you how fast it's moving. The government of India right now is also aggressive about raising the fuel prices to make people migrate towards renewable energy, especially for cars. Petrol prices have almost gone up by close to 40%, and people are migrating towards electric vehicles, and people are moving towards renewable energy sources such as solar to charge their electric vehicles. So I hope I've answered that question because this is too big a topic and I don't have enough time to answer all of it.
Right. We are almost about to wrap up the session, but it is in line of the same explanation you have given it. But let us listen your view on this. There is a question, how the cost of production trend over a last decade and where we are moving forward in next 5 years with respect of cost of solar energy production.
One of the challenges with solar energy is the inefficiency of converting solar energy into electricity. A typical solar panel, a monocrystalline solar panel, converts only 20% of its energy. In fact, the most efficient solar panel, I think it's a Panasonic panel, is 21.3%. So people are a little hesitant about that. They are waiting for technology to improve. Elon Musk has got some beautiful solar panels that he's putting out. So as solar technology improves and gets enhanced and the prices start coming down, people are going towards solar system. The prices have dropped by almost 50 to 60%. So imagine if today you're spending $30,000 for a very large solar system, it used to cost maybe around $150,000 before. And in the next 10 years, that same will cost you about $10,000, which is around 3,000 dinars. So you can install a solar system for a typical house for about 3,000 dinars in another 3 to 5 years. In addition to this, batteries are very expensive, very inefficient, and carry a lot of risks. So once we get a technology that can store energy for night use, then you can see a lot of people migrating towards solar energy. Right now, the challenges that we're facing with batteries are they're bulky, they take up a lot of space, there's environmental issues for disposing them off, and charging them is very inefficient. So you can lose as much as 30% charging and equal amount while discharging. So solar, as long as there is solar out there, we have to look at other forms. And this brings us to the next thing. People are now moving towards a combination of solar energy and wind energy. So wind can work round the clock to top up and charge your batteries in the night and used in areas where, especially coastal areas. And in addition to this, you can get your battery, you can get your solar in the daytime. So these are hybrid systems that are coming out, hybrid renewable energy systems.
Thank you, dear Anil, for your wonderful explanation. And I hope we have all answered question answer. Those who have joined this session late, they can still have a chance to visit to our SSP YouTube page. They can catch up it on their convenient time. There is another question which is coming up. We will wrap this whole session in another 5 minutes. Bear with us since it's very interesting and new openings are there. People are curious to know that. What are courses you recommend for renewable energies? Any thought on this, dear Anil?
Yeah, there are a lot of online courses that are available. People can Google that. But more than that, there are some universities that offer diploma programs as well as degree program in renewable energy. The university in Dehradun that I studied at is called the University of Petroleum and Energy Studies. And they have programs on renewable energy. They have certificate programs as well as diploma as well as and degree programs. In the US as well as Europe, there are programs on renewable energy. There are degree programs for bachelors as well as master's program. There are a lot of research being done right now on solar panels and solar components. A lot of major universities, TUE in Netherlands is working on that, and so are other universities. I have been collaborating with a few of them in trying to get mobile solar systems for certain applications, especially in India. In India, I'm working on a project for pollution monitoring equipment in remote areas. So they have these mobile vans that get parked in certain forest areas or industrial parks, and they need to run on solar energy so they can monitor the equipment. And in the nighttime, when the electricity, when there's no sunlight, they have to run it on batteries. So there are a lot of companies and a lot of organizations that are working on R&D for this, and a lot of major manufacturers who are getting into this. Tata is moving into solar manufacturing, so is the Adani Group. Samsung, LG, Panasonic, they are into this. And a lot of battery manufacturers, Okaya, Exide, they are moving into different type of lithium batteries. There is a newer technology of lithium batteries, which are more stable. From lithium ion, they're moving to lithium ferrophosphate. So they tend to not catch fire and explode as much. They are also more resistant to vibration, so they're being used in vehicles, in automobiles, rather than having liquid-cooled battery packs. So you can go online, and those of you who want to study more about this can send me a private email, and I'm sure you'll share them the details, and I can help and guide you. Because remember, this is the future. Renewable energy is the future. Just like petrol once upon a time was the future in the last decade, our next decade and next century is going to be on renewable energy. So whoever masters and learns about renewable energy is the IT guys for the future.
Thank you, dear Anil. Because of time constraint, we will be not taking further question, but I promise you I will get back to your answers when I have a personal time with Mr. Anil Lobo. Now, this is time for facilitation to the speaker. As a token of appreciation.
Thank you.
Please accept our small, this digital memento
Thank you.
for DTM Anil. And next we will be moving it for online quiz. There will be no winner announced, but since you have already participated in online poll, but you will be able to get certificate of participation. So kindly participate on online quiz. Ramana, can we have this quiz on chat box? Ramana? Yes. So the online quiz is already posted. Kindly spare a few minutes to answer it to get you a certificate of participation. I guess all these participants are busy in answering the question. Thank you for all who has spared their time to listen to our eminent speaker on this very useful topic, which will be the future in days to come. And still there are a long way to go. So, kindly participate on this online quiz. Ramana, I hope we have got that answer now.
Yes, let's go for another 2-3 minutes. And,
Yeah, so 2 more minutes to go, and then we will.
now we can open for networking. Let it go for some time.
Okay, the floor is open for networking. We will be open for another 5 minutes. We apologize for overshoot of this. As the topic was very interesting, and we cannot avoid the curiosity of the participants. So please excuse us for another 10-15 minutes. Now the floor is open for networking. If you have any query and concern, you can have a chat on that. And officially within 5 minutes, we will be closing the session itself. Okay, Ramana?
I'm going to be dropping my email.
Great, Jer. That will be great. Yeah.
So you guys can get in touch with me. Any further questions that you have?
Yes, sir.
It's the Reis.
Hello? Ramana?
Yes, Ashok sir would like to talk.
Okay. Mr. Ashok Garlapati sir is online. He want to convey some message to us.
Yes, I just raised the hand, Sabdar. And
Yes, sir. I understand it's hard to hear from you. You are very far located, but it's nice to hear.
no, that's what you think. I came back yesterday itself.
Oh, great. Right, sir.
No, I just want to see the chapter gives a lot of light on many things, but I didn't know Anil Lobo has got another side of export, which is renewable energy. Wallah, we shared a lot of knowledge today. Thank you, Anilji. Wallah, very nice. I mean, I got so much of information for the last 1 hour. And I asked the question, in fact, the course, I know this is very upcoming field and we need to gear up for that. So thank you for sharing all the information, Anilji, and appreciate your time as well as throwing a light on your another side of expertise. I didn't know that you are expert in this field, but thanks to know that and thanks to Kuwait Chapter for getting this opportunity. Thank you very much.
Thank you, Ashok. But today's presentation was a basic that I've given you because I have my own solar business that I'm running here. It's more consultancy as well as installation. Although I specialize in off-grid system and hybrid system, we work on big government projects. So we have the expertise to design as well as to rectify other people's, miscalculations as such. And we work with cutting edge technology. Lead acid, I don't like to work with because of the environmental issues. I'm a big environmentalist. So I'm migrating towards lithium ferrophosphate. They're much easier, more stable. They don't catch fire as lithium ion batteries do. Also, they are easier to transport and handle. You can drop a lithium ferrophosphate battery, and you can repair it immediately. You drop a lithium ion battery, it will blow up in your face. So there are a lot of things I can talk about. I can give more advanced, smaller workshops for people who are interested in this, especially for those who are interested in pursuing this as a career, because there's a big career opportunity in this.
Maybe our chapter can think of having some 10-hour course or something like that on this, that will be good to know.
Yes, I could do that. I can conduct some course on this modules.
Excellent.
Okay, we'll look forward for your participation and we will work towards it. Now I can see Mr. Dinesh Paul has raised his hand, and after that, Mr. Ojo Tajuddin. Ramana, we can stop the streaming on YouTube, right? Let us hear, but keep your question very limited